All right, ladies and gentlemen, so our post-lab for the protein denaturation. You have your choice, hand it in as a pair, collaborate, write it as a pair, or if you want to write it on your own, do that. Just please agree before we start, okay? 3 elements to your lab report writing. Number 1, a good table of observations. This is not a formal lab this time. So you can start right with a table of observations. Make sure it has proper title, proper headings, proper units if there are units involved, descriptions. In this case, you're really describing the extent of the cloudiness or the opacity. Okay? So and you can give it a number rating or something like this, so it's very easy to do. So just make sure it's clear. That should be 6 easy marks. Here's where the meat of it is. 5 times 2 marks for the 5 different tubes. Start with your control. Why did you do the control? You added water to it, kept it at room temperature. Why did you do that? So discuss that. Each of these should take around, a paragraph, 3 or 4 sentences to describe. Then the one that you added acid to. What did you really add when you added the acid? How did that affect the protein in there? How did the protein respond? Similarly, when you added the base, what really did you add or subtract when you put in sodium hydroxide? How did the protein respond? That, of course, will tie in nicely later on to the extensions when you try to reverse it, right? Similarly, the one that you added heat to. You didn't add acid or base, you added kinetic energy. So discuss what the kinetic energy may have done to that protein, like what we talked about in class. Similarly, the one that you chilled on ice, you removed kinetic energy. What did that do? So you might want to talk about van der Waals forces, right? And those sorts of things. As you describe this, remember what we learned. We learned about the R groups, the charges on them. We talked about kinetic energy, solubility, proteins precipitating, polar and nonpolar R groups, stabilizing structures. Were they affected by what you did today? Van der Waals forces, hydrophilic, hydrophobic interactions. All of these things came into play in the simple observations you made today. So each of the tubes describe and explain what's going on. Then finally, the 4th part is where you do the extensions. A lot of you try to reverse your reactions. And you saw, especially with the acid and base, you go back and forth, right? And explain why that is so. And that should be a fairly straightforward marks. Now, Clark, where are you? You said you did something. You went back and forth acid and base, and then you did something else.
Okay, what we did, so for NaOH...
We need a film on Clark. Yeah.
For NaOH, so we added NaOH to the egg albium, and it went clear.
Mm-hmm.
And then we added HCl, and it went foggy, obviously, because protein clumps formed. And then so we added 5 drops of HCl. Then we added another 5 drops, so that's 10 drops, and it went clear again.
Mm-hmm.
So we noticed that it hydrolyzed the proteins, which means it broke them apart,
Good.
making it go clear again.
Excellent. So it actually did hydrolysis reactions. If you had too much acid, it cuts the protein into individual amino acids. All right? I just happened to find this over here. Here's a soup. If you look on the ingredients of soups and things like this, you'll notice there are ingredients such as hydrolyzed soy protein, hydrolyzed corn gluten, that's another protein, right? You will often find when they add flavor to soups and sauces and things like this, one of the ingredients will be hydrolyzed vegetable protein or some kind of a protein where they're cutting it up, so you're still getting some of the flavor. They're usually not cutting it right down to amino acids. They're doing a limited treatment with acid, and that gives some flavor enhancement in a natural way. It's one of the ways that we get natural flavor added. Okay. Good? Any questions on the lab report writing? No. You now have 25 minutes to collaborate and begin. Thank you. Cut.